Hey there, this is Horner, and today we're going to go over volcanoes. This is my version of notes on volcanoes. So, where are volcanoes found on the Earth's surface? So, let's first go through and define what a volcano is. It's really just a mountain that forms in the Earth's crust when molten material or that magma reaches the surface. Remember, magma is just that molten mixture of rock, forming substances and gases and water that all come up from the mantle. Once that magma goes up into the volcano and then comes out the side or maybe comes up through a crack in the surface of the earth, we call that magma that's reached the surface lava. So to go back and review, we really need to know the definition of volcano, and that's just a mountain. Remember, it forms in the earth crust. We have a lot of molten material or magma that reaches the surface. Once that magma does reach the surface, then we call that lava. And magma is just a mixture of rock forming substances like gases and water, and then all kinds of different minerals and things. So let's take a look at the next one. Volcanic belts form along the boundaries of Earth's plates. So if you think about all the different tectonic plates, there's a really cool one in the Pacific Ocean that we call the Ring of Fire because there is a ring or a whole bunch of ridges here that have volcanoes in them. Some of them are above ground and a lot of them are underneath the ground. And this is what we call the Ring of Fire. Very important. So volcanoes, as we said, can form at a lot of different boundaries. One of those boundaries are diverging boundaries, and the other boundaries are called converging boundaries. So we've talked a little bit about those. Let's take a look at first the volcanoes that we'll see in diverging boundaries. If you remember, we had seafloor spreading, and in that seafloor spreading, we have something called a mid-ocean ridge. And sometimes you'll have a volcano that forms under the water. And when it does that, it can create a lot of steam and things that you'll see come out of the ocean. But these diverging boundaries in the ocean will form at mid-ocean ridges, and so you can have some volcanic activity under the water. You can also have volcanic activity up on the land. Large land volcanoes occurred along the Great Rift Valley in East Africa. And remember, these are formed by diverging plate boundaries. So they create something called a fissure eruption, and they will also create something called a shield volcano, which we will look at later. This is a native person from Africa. This is he's probably from the Maasai tribe, which is really kind of cool. And you'll see all the different plates here, but this happens pretty close to Kenya, and in Kenya we have these Maasai people, and so they see a lot of this activity happening. Volcanoes at converging boundaries are a little bit different. So remember, at converging boundaries, the two plates will actually come together. And sometimes one plate will sink underneath of the other one. So we call that subduction. And remember, it makes a trench. So we can also see subduction here from the oceanic plate into the continental plate. When that happens, sometimes you'll get some lava. It's some magma in the earth that will move up, and then remember, when it comes out of the volcano, we call that lava. So fluids sinking and the sinking plate becomes superheated, they escape, and that rock does melt and it forms magma right in this area. When that melting and all that happens, you'll also get some earthquakes, but then you end up with a magma rising up to the surface, and that erupts and forms a really cool volcano right there on the coast. Volcanoes at converging boundaries also will form something called an island arc. So these are volcanoes that result on a converging boundary, so you can kind of see one here. And they create these strings of islands, and we call these islands island arcs. So they come up out of the water, so you can kind of see the water level here, and then you see these volcanoes that are sticking up out of them. So you've seen these before. These happen to be islands from Japan. They form New Zealand, and I've been to New Zealand. Very pretty country, very hot country in terms of all the sulfur springs and the volcanic activity they have. The Aleutian Islands and finally the Caribbean Islands are formed from converging boundaries, and we do call the Caribbean Islands an island arc. The next slide that we have here talks about another phenomenon we call a hotspot or a hotspot volcano. This is just an area where material from really deep within the Earth's mantle It rises up through the crust, and when it melts, it forms magma. So that volcano will form above the hot spot when the magma erupts through the crust and it reaches the surface. So notice that there's no plates here colliding. They're not diverging, they're not converging. Instead, we just have this magma that just kind of rises up from deep within the mantle, and when it does that, it can poke all the way through, and it forms these hotspot volcanoes. So typically, these volcanoes are called something called a shield volcano, which we're going to look at here in a little while. Kilauea in the Hawaiian island, on that big island. This one is in the ocean. And then you also have some of these hotspot volcanoes on land. And Yellowstone National Park actually has a huge volcano there right under it. And so we say that that is one of those hotspots that are on land. So once again, we can see them both in the ocean and on land. Inside of a volcano, there are many different structures. One of the structures that your book talks about is called a magma chamber. And this is just basically a pocket of magma. It's beneath the surface where all the magma collects. The pipe is the long tube that extends from the surface of the earth, goes up through the Earth's crust and up through the top of that volcano. So we've got our magma chamber where you might have some magma underneath the surface where all that magma will collect. Then it travels up the pipe, which is a long tube that extends just from the crust of the Earth up through the top of the volcano. The vent is the opening where the molten rock and gas leave the volcano. So when you've seen pictures of volcanic eruptions, that's coming out of the vent. And then we do have lava flow, and the lava flow will spread out lava as it pours out of the vent. And then it forms new rock, and we end up with our mountain. A crater is just a bowl-shaped area that may form at the top of a volcano around that central vent. Remember, the vent is the opening where that molten rock and gas do leave the volcano. So our 5 different parts again are the magma chamber, we have the pipe, the vent, the lava flow, and finally we have the crater. So that's the inside of a volcano. We've got a picture in your notes that we're going to go through and fill in. So all the parts that we just talked about, the magma chamber, pipe, central vent, we've got a little vent called a side vent also, the lava flow, and a crater. So let's go through and fill all these in. We're going to start with the one right here. And this one is called the central vent. So this is where a majority of that magma will make its way up the pipe and then out of the volcano. Just to the left of that, you'll see over on this other volcano, so you'll see at the very top, this is the crater. So the central vent would be down inside the crater. Then we have the crater itself. Over to the side, we have some lava flow, lava flowing down the side or the outside of the volcano itself. So notice this is a cutaway of the volcano, and you can see all the parts coming up. You can see all the layers that have been created on the volcano, so it just keeps building. On the other side, this is a side vent. So we've got the central vent right in the middle, and then sometimes magma will come through the side of the volcano. We will call that a side vent. The tube that comes right up straight through the middle of the volcanic formation here is called a pipe. And then down at the very bottom, we have the magma chamber where we have all the magma rising up from the earth, either through that hot spot or from some sort of divergent or convergent boundary. And those are the different parts that you'll see to the volcano. So one more time, we've got the central vent at the top, right in the middle. We have the crater that would surround that, so a good picture of a crater over here. We have the lava flow on the outside. We've got that side vent over on the side where the magma is making its way out, turning into lava. We have a pipe right up through the middle, and then that pipe is fed with magma through the magma chamber. Some other landforms that lava and ash create, we have shield volcanoes, we have some cinder cone volcanoes, composite volcanoes, and then we've got some other things called calderas, fissures, and lava plateaus. So the volcanic eruptions do make landforms from lava and ash and other materials. So all those materials will make these different items. So the shield volcano, cinder cone, and the composite volcanoes. So let's take a look first at shield volcanoes. Shield volcanoes basically are formed anytime you have thin layers of lava that pour out through a vent and harden on top of previous layers. So you kind of see a picture here of the different layers that we form as the volcano gets bigger and bigger. So you see the solid lava layers, and then we've got some other layers here that might not be as dense, and these are gentle lava eruptions. Lava flows slowly, build a wide, very gently sloping mountain like the one that you see here. This is Mauna Loa in Hawaii. And so we call these shield volcanoes. So it kind of looks like a shield on the outside, hence the name shield volcano. And that is the first volcano. The second volcano that we're going to look at is called a cinder cone volcano. So this one's got a very distinct shape. You can kind of see the shape to this volcano here. Volcanoes that erupt very explosively. So if we go back to the previous volcano, this one erupts very slowly. So we could call this a quiet eruption volcano. And then we have explosive eruption volcanoes. And a cinder cone is one that does this. And it erupts explosively to very high silica content in the magma. Remember we said that the Earth, a lot of the rocks have a very high silica content. So volcanoes that do erupt explosively have very high silica content in their magma. Materials will build up around the vent in a very steep cone-shaped hill or a very small mountain. So we call this a cinder cone volcano. Parcutin, I think is how you say it, in Mexico, is a cinder cone volcano. You see a picture here. You actually see where they built a road to kind of go up the side of the volcano so you can get up in there and kind of look around a little bit. When they do explode, they explode very violently. We're going to talk about volcanic bombs here in a little while. And you'll kind of see that in the ash cloud and how dangerous these two things can be. Going back, we have that vent again, or pipe. Sometimes it's called a pipe, sometimes they call it a vent. We've got our crater up top. We do have the different layers in this cinder volcano, and then the lava on the outside, the magma chamber down in the bottom, and the magma that makes it up. The next type of volcano, this is the third type, is called a composite volcano. So this is a volcano that can erupt very quietly. So it's got quiet lava flows, and it's because it's got a, it can also very violently erupt too. So both erupts quietly from lava flows and explosively, shooting out a lot of those bombs, lava bombs, due to varying silica content in the magma. So some of the magma might be very low silicon, and the other might be very high silica content. So when it's high silica content, remember it's explosive eruptions, and when it's very low silica content, it's a very quiet eruption. So Mount St. Helens is one of those volcanoes that will do this, does a little bit of both. So sometimes it'll blow its top like it did, and wiped off a lot of the mountain. You actually blew a big hole in the side of the mountain, and sometimes it'll just erupt with lava, but you can see the huge plume of ash and smoke coming out of the top of this one. A caldera is a result of just a volcano that's collapsed. So this volcano erupts, and then over some time, everything gets very weak around it, and it'll collapse. And a lot of time, these calderas will fill in with water, and so you'll see a lake inside this volcano. Sometimes that water can be very, very warm, or very, very hot from the magma that's underneath it, then interacts with the bottom of the lake, and it heats that water up. Sometimes that water will grow some really cool bacteria and will appear very, very kind of bluish green, which is kind of cool to see. So that is a caldera. It's just a big hole left when the volcano collapses. A fissure eruption is another phenomenon that we see on sometimes just a little bit away from a volcano. So you can kind of see here's a central volcano here, and then we'll get some magma that will kind of move out in a lateral way, and then we get these fissure eruptions where the earth just kind of opens up and you get a lot of lava coming up through. So magma underneath, and then lava is up on top. So lava is just flowing from very, very giant cracks in the earth or fissures. And these either come from something called a lateral dike, or it'll come from something called a subvertical dike, one of the two. Just depends on how this flow is happening. Coming from the magma chamber. Either it comes from below the magma chamber, or it will come from just the side of that magma chamber itself. So that's a fissure eruption. The next thing is called a lava plateau. And this is a thick and mostly flattened layer of cooled lava. So what happens is we get some fissure eruptions, And those fissure eruptions over time, the flow will flow down a kind of a mountainside or a hillside, and you get these plateaus. And so we call these lava plateaus because lava just builds up and it forms a thick and mostly flattened layer of cooled lava. So that's a lava plateau. For the very next slide here, there are some geothermal. So geo, earth, and thermal just means heat, features. These are features on the landscape that are caused by heat from the Earth's interior. So you can see a lot of these. These are typically in areas where there's volcanic activity. The very first one here is called a hot spring. So you can see this really kind of cool bluish color here and then kind of the yellow color on the outside from a lot of the sulfur. The water in the hot springs is geothermally heated by the Earth's crust, and some of the springs are just the perfect temperature to bathe in. And then some of them are so hot that they would result in injury or even death if you tried to get into them because they're just scorching hot. So that is a hot spring. The next one is called a fumarole. A fumarole is just basically steaming holes in the ground. In these steam holes, you can have water from the ground comes into contact with magma and it immediately turns into steam. So if you've ever taken water and you poured it into a skillet, a really hot skillet, and all the steam comes up, that is kind of like a fumarole. The next one is called a geyser. Probably the most famous geyser that we know of is Old Faithful. That one erupts every 60 to 80 minutes, and that's why we say it's Old Faithful. But this is just a vent in the Earth's surface, and it shoots out a column of hot water. So it takes a little bit of time sometimes for these to recharge, kind of like Old Faithful, but Old Faithful does it very faithfully every 60 to 80 minutes. The last geothermal feature that we'll look at here are called mud pools. Really kind of a cool type of thing to look at. They're called mud pools or mud pots. And they're an acidic hot spring or fumarole. So it's just a type of fumarole. And the acid causes the surrounding rock to form into mud or clay. And it looks like it's boiling. Sometimes they use these in movies to kind of make things look kind of creepy and kind of eerie. But those are really kind of cool to see. The next slide here talks about hazards and side effects of volcanic activity. Probably one of the worst things to have happen is a pyroclastic flow. And in these, we just have fast-moving hot gas and rock. It basically is just an avalanche of really hot gas. So when Mount St. Helens erupted, you had all this pyroclastic flow down, and anybody or anything that was in the way basically just got burned up by this extremely hot gas that was just moving right down the hill. The blast can flatten houses and trees, and it burns everything down to a cinder, so it's extremely hot. The next one is a mud flow. This is called a lahar, and when we look at it, after a volcanic erupts, ice and snow can be melted from the heat, and it runs down the hill. And this can last for many, many years on hillsides. When it rains, the ash and material travel downstream. So that was that one. And then we also have something that occurs with earthquakes. Remember, a tsunami can occur from an earthquake, but volcanoes can also create tsunamis. Remember, these are just huge sea waves created by an earthquake or other geographical disturbance happening anywhere in the area of a volcano. So those are some hazards and side effects of volcanic activity. This is the last slide, so these are the last three hazards and side effects of volcanic activity. The first one is just that actual lava flow itself. And obviously it's really dangerous because after an eruption, that magma pours from the vent and that creates that lava flow. And that lava can knock down buildings, it can set fire to anything that can burn. So it runs into a lot of different things, trees, buildings, cars, anything that's in the way that can't get out of the way. The next one's kind of cool. These are called volcanic bombs, and you can kind of see a picture of a volcanic bomb here. And this is just a mass of molten rock that gets ejected or catapulted from a volcano during an eruption. If they go and they hit a house, they'll just burn right into the house itself. They're kind of like cannonballs shot out of a volcano. And then the last thing that really is damaging is ash. In fact, whenever an airplane flies If it flies into a cloud of ash, that ash will actually get into the engine and makes the engine stall out, can ruin the engine, and the plane will have to make an emergency landing. So clouds of ash from explosive eruptions, they can also suffocate and often are very, very scorching hot. If they're hot enough, they can start fires and they can burn whatever is in their path. So that's that hot ash. So we have lava, we have those bombs that we were talking about, and then finally we have really hot ash. And that is the end of this PowerPoint.